What is the influence of sulfur on the weldability of stainless steels? In this video, I will give an answer. Hello, I'm Jan Rau, Quality Manager of DOCKWEILER. During my day-to-day work, I'm often asked why sulfur, a trace element in austenitic stainless steels, has such a major influence on the weldability. I'm currently also chair of the ASME BPE subcommittee on metallic materials, and I very well remember my first BPE meeting many years back where I asked that very question by myself. BPE stands for Bioprocessing Equipment. The BPE committee works on standardization of systems for the pharmaceutical, biotech and biotech industry. The background of the discussion on sulfur is the repeatability of orbital gas tungsten arc welds, the joining method of choice for piping systems in the pharmaceutical, biotech and semiconductor industry. To understand the strong influence of sulfur, one should know that surface active elements such as sulfur, oxygen and arsine have a major influence on the mass flow in the liquid weld pool during welding. Anyhow, it is sulfur that has the greatest influence. This is because heats with very low sulfur tend to show a so-called divergent mass flow. That means that liquid steel is flowing from the center of the weld pool with the highest temperature directly underneath the arc, flows towards the colder edges, discharging thermal energy towards the edges. From a sulfur level of 0.005% and upwards, this mass flow turns around and thermal energy is transported into the metal itself, enhancing penetration during welding. This effect is shown in the following microns. The first micron shows a full penetration weld of two heats with very low sulfur, showing a very narrow root width. The second micron shows the weld of two heats with higher sulfur levels, indicating a wider root width, so a better penetration with the same amount of heat input. But sulfur does not only have beneficial influence on welding, it may also show a detrimental effect. It was published a couple of years back in Stainless Steel Worlds that very smooth ID weld root surfaces can be obtained by welding heats with extremely low sulfur. Anyhow, the most important effect of sulfur on the weldability shows up when we weld two heats with different sulfur levels together. If the difference in sulfur is high, then the arc deviates towards the component with the lower sulfur level. In an extreme case, this may result in a lack of fusion on the ID of a piping system, definitely not acceptable in the pharmaceutical and biotech industry. This effect is clearly shown in the following video stills, once recorded by Barbara Hannon art machines. The first still shows a very symmetric arc when the two sulfur levels of the components are comparable or perfectly the same. The second still shows the arc deviation towards the low sulfur heat with 0.002% sulfur. But we also can observe this phenomenon in our day-to-day work, as indicated by this image showing the result of a dye-penetrant testing. The red line indicates a lack of fusion between these two components. One component was a longitudinally welded tube with a typically very low sulfur, and the other component was a machined component from bar stock with a much higher sulfur level. This was the reason for the lack of fusion in this particular case. To ensure repeatability of orbital gas tungsten arc welds in critical industries, standardization institutes tend to control the sulfur to a much narrower band as specified in basic material specifications. In this regard, two standards should be mentioned. One is the ASTM A270 with a supplement pharmaceutical quality tubing. The other is the ASME BPE standard. Both standards specify a minimum sulfur of 0.005%. At the same time, these standards specify an upper limit of 0.017%, both to facilitate welding components with different product forms and maybe different sulfur levels together. The following recording shows a high quality weld obtained in the as-welded condition, no post-weld treatment applied when the sulfur levels are within the controlled range. It is without saying that it is possible to achieve such high quality welds without the sulfur restriction of 0.005 to 0.017%, but it certainly makes life much easier for the welders. I hope this short video helps to explain the influence of sulfur on the weldability of austenitic stainless steels. If so, please follow us on this channel. If you have any other question, please feel free to contact us.